Hello, everybody, and welcome back to our latest episode of the Utopias podcast. This is a conversation I had a few months ago with a person I believe is a rising star in the field of artificial intelligence, and really someone in Sayash Kapoor, a PhD candidate at Princeton University in computer science. But he's really someone who bridges our technical understandings of AI and emerging technologies with policy, societal impacts, ethics, and so much more. I think you're going to find this conversation to be incredibly illuminating and very, very helpful, getting us a sense that, hey, we can really understand what these AI systems are and what they're not, because many of these systems are, as he puts it, examples of AI snake oil, which is a wonderful co-authored book that Sayash published just this past year. So Sayash's research looks at the societal impact of AI. He's the recipient of a Best Paper Award at the ACM, which is, a leading academic consortium on research on AI. And he was actually included in Time's inaugural list of the 100 most influential people in AI. So this is a great conversation. I think it's something that anybody can follow about what the downsides are of AI, the upsides of it, what it is, what it isn't, the connections to geopolitics, the fact that many AI systems are being led full on, at least in the United States, by private corporations, and how there could be many different challenges that we've already run into with social media that could also implicate AI. And the power of thinking systemically, economically, politically, and ecologically as we think about any technology, including AI technologies. So we get into a lot of news items, news hooks, including stuff related to Chinese AI, like the DeepSeek versus OpenAI. And this is just a very, very refreshing conversation that I hope all of you enjoy. So thank you all for tuning in. As always, please rate and review and share our totally non-commercial podcast with anybody and everybody. We depend on all of you so we can continue this labor of love that is the Utopias podcast. Thank you. Sayash, welcome to Utopias. Thank you so much for joining us today.
Thank you so much for having me. It's a real pleasure to be here.
Thanks, Sayash. So we're going to, kind of communicate this to our largely lay audience, which includes some students across the UC system, but a much wider set of audiences as well. I think I just want to start by demystifying AI, specifically this generative AI that is kind of capturing people's attention. Sometimes they're paranoia, sometimes they're fantasy, all of these things. So when we talk, let's just kind of talk on a very basic lay level about how these generative AI systems like ChatGPT, but also DeepSeek, how they function. What actually do they do and what do they not do and how do they work? Like if you can explain it in a super lay way.
Absolutely. So I think a lot of the recent advances in generative AI actually go back 80 years. So I think for the last 8 decades or so, computer scientists across the world, across different universities, have been looking at how to create models that can learn patterns from data. In the book, we sort of talk about this ladder of generality of computing, that as we have progressed in computing, we are basically moving towards systems that can be easier to use and program for the end user. And I think there are 3 sort of recent steps on the ladder of generality that can be helpful to think about how AI works. The first is machine learning. So machine learning broadly refers to learning patterns from data. So for the last few decades, there has been a lot of work on building better systems that can do this type of work. For example, in the late 80s and early 90s, we already had systems that could look at letters and numbers, and they were already being used for character recognition by the US Postal Service. Fast forward another decade and a half or so, in the early 2010s, we had another fundamental breakthrough called deep learning. So this was basically the insight that we don't need to do anything fancy to scale up the capabilities of earlier, simpler machine learning models to perform much better image classification. Rather, all we need to do is to increase the size of the models that we're using to detect what's in an image. So for example, given enough photos of images of cats on the one hand and dogs on the other, a deep learning system could very reliably detect if in a new image there is a cat or a dog. And a very similar thing actually happens if we look at modern generative AI systems, except the labels, instead of being labels of cats and dogs, are actually automatically generated on the internet.
Mm.
So let's say there is a sentence somewhere on the internet, on some random part of the internet, on some random website that says, "What is your name?" To create language models, models like ChatGPT that can interact in text, in language, all we basically do is we turn this sentence into four examples. The first example is, "What is your blank?" And the correct answer is name. The second example is, "What is blank name?" And the correct answer is your, and so on and so forth. So these are the four examples.
Mhm.
And we do this for every single sentence that we have access to in our data. So we take all of the data from the internet. In many cases, companies are relying on private licensed data, such as from news organizations that have paywalls. And we keep repeating this basic process over and over again. And that is the core sort of principle that makes modern generative AI work. It is very much say the same as earlier machine learning methods, at least in principle. But the key differences are the scale of the models is much bigger, and the data we are using it on is also much bigger. And because we can automatically generate these labels, we basically have access to trillions of words in the corpus that we use to train these language models.
So basically, data is somehow able to be labeled or categorized because there's more and more data that can essentially be inductively classified in such a way.
Exactly.
Got
Exactly. And
it.
if you think about what a language model then learns to do,
Mm.
essentially at each point, it is basically predicting what the next word in a sentence will be, given previous words in that sentence. So the previous words in a sentence could be a user's query, "What is the weather today?" And the language model will try to answer what the most likely next word in the sentence is, given all of these previous words.
Really interesting. So, as someone who used to be an AI developer in my time at the Media Lab when I was a graduate student, I was a student of Marvin Minsky's, and we were trying to think a lot about meaning and common sense. We were very interested in the idea of how do humans, first of all, I don't know if all intelligence is restricted to human beings. I mean, but aside from that, Dr. Minsky sort of argued that common sense was the most hard nut to crack, but we could try to build technologies that could interpret and make meaning, actually semantic is the word we often used, in a way that was somewhat similar to the way humans function. But it sounds like these systems are quite different because they're basically more data, which means better patterns, is better in these systems. Is that an appropriate characterization?
Exactly. And I mean, people have arguments even today at the forefronts of cognitive neuroscience as to whether
Yeah.
these systems actually understand the world or whether they're just mimicking these patterns.
Yeah.
And I think if you think about it as a spectrum, on the one hand, you have something that is just a stochastic parrot, if you will. It keeps sort of outputting patterns in the data. And on the other hand, let's say you have something that truly understands meaning for some definition of the word true. LLMs, I think, language models are somewhere in the middle.
Mm.
So you do have certain senses in which, language models do truly understand the meanings of certain words, especially because they can answer questions about words in a variety of different contexts. They often know which definition of a word a given sentence is referring to. Let's say for a word that has many different definitions, it can basically uncover what the referent is.
Yeah.
But on the other hand, when it comes to things that would actually require deeper sense of reasoning, so let's say if you have like some basically very simple word riddles, they're enough to trip up language models, even despite the fact that they have been trained on trillions of words in the English language.
This is the distinction actually that some philosophers call the distinction between reason and instrumental rationality. Not to get too philosophical about this, but reason is about dialogue, it's about interpretation. Sometimes reason can also be tied to irrationality, to be quite philosophical about it. So how does a machine actually understand and make meaning in this sense outside of the mere, kind of mere like things like understanding semantic thesauruses, or to be a little technical about it, proximity distributions. I'm just curious. This is actually a question I've always wanted to ask you.
So, I mean, to be precise, I think we don't really know. And there's this entire field of
Yeah.
what is called mechanistic interpretability, which
Mm,
is trying to understand how language models function on a mechanistic level. How do individual neurons interact with each other? And there have been some successes from this community. So, for example, we've had some research papers for much simpler neural networks, let's say, I don't know, 6 orders of magnitude smaller than the state of the art models, that have actually very precise information about a particular neuron signifying the country France. So let's say you take a bread and activate that particular neuron in the neural network, the
mm.
output would be a baguette, for example. But I think there is still a lot of room for research here, simply because even at this mechanistic level, these neurons can be correlated with a number of other different neurons, right? So you can think about these neurons in isolation, but what is more important is what happens when networks of these neurons operate together. And I think it's just really hard to be able to do that on a mechanistic level.
Yeah, because probabilistic inference, or which is sort of tied to stochastic models, which is kind of what these things are sometimes derisively described as by some of our colleagues like Timnit Gebru and Kate Crawford and others. Some of those, when you say it's a stochastic parrot, stochastic means probabilistic inference. Everybody who's listening, parrot is like parrot mimic, like the way a parrot mimics us, right? So it's a mimicry of expression. I think that interpretation and reason is more than just parroting, but it could be about relations, semantic relations. Like, this window is, I can somehow connect this window to the window I see in the car on the road. It's not a great example, but basically, I'm able to go across, I don't know if you would say domains, to look across different classes of objects, but to see a connection by the commonality of this window. That's the first thing I came up with. But so I think there's something there that actually part of reason and part of interpretation is about relation that's not just about patterns. Is there something there? I'm just kind of speculating as I'm listening to you.
Yeah, I think there is. But at the same time, I
Hmm.
think it's hard to describe that reasoning process
Yeah.
mechanistically, right? So
Yeah.
it's hard to say that no probability distribution over words would ever be able to basically act in a way that sort of satisfies all the characteristics we hold would hold true for reasoning. And I think that's what the debate in like cognitive neuroscience is about. Is
Yeah.
there like a there when it comes to language models, or are they basically just like outputting words? And mechanistically, of course, that is what they're doing. But do they really sort of understand deeper concepts? And so far, I think the debate is open, and I think we need a lot more research to understand this. I think the question that is like more interesting to me is, irrespective of these sort of shortcomings of our understanding of LLMs, even if we don't understand the nuts and bolts at the mechanistic level of how these language models work, if you will, I think it is still it is still very interesting to me to be able to look at these systems as black boxes and take what we can in terms of how they can operate in the world. So, can we sort of, even if we forget about how the internals of the language model work, what are the domains where we should be using these language models? How we can sort of work around their limitations of the lack of reasoning or the lack of reliability to make systems that, irrespective of how they're working internally, still contribute to systems that work well in the real world.
In a sense, sort of unblackboxing here may not be interior to the model, but also in how the model works in relation to other parts of the world, other technologies, other infrastructures, and so on.
Exactly. And so Joshua Kroll has written this wonderful essay called The Fallacy of Inscrutability,
Yeah.
where he says that, oftentimes we take these machine learning systems as inscrutable and see that as a reason for not deploying these systems or for pushing back against their deployment. But actually, the relevant property of these systems is not just like scrutability at the atomic sense, or at the atomic level. Like, it's not scrutability of every individual neuron, but rather the behavior of the system as part of a whole. And
Mm.
so what matters much more than sort of this individual neuron level understanding is being able to tweak the system, to tweak the inputs and observe the outputs, to sort of treat it as a scientific process of understanding how the system works in various settings, rather than simply trying to understand the mechanistic aspects of how the system works.
Super interesting, because that approach gives us a sense, and this is really the core of this podcast, that we, all of us around the planet, have some power over all of these technologies, that actually we can play with them and understand, maybe not trial and error, but through some sort of experimentation, playfulness in a sense, what they do and what they don't do in different contexts.
Absolutely. And I think unlike many other types of AI systems, which were mostly developed for business use or for enterprise applications, I think generative AI has been unique in the amount of consumer reach it has. So for
Yes.
anyone looking to understand how well these systems work, systems that are very close to or at the state of the art can be accessed by anyone with a mobile phone and an internet connection. It does not require like this deep sense of expertise. In fact, it's quite the opposite. The people who are best suited to analyze how well generative AI works, in my opinion, are those who are already doing tasks that they would like to see generative AI automate, or at least automate parts of it. So in other words, like this is a funny observation that people have often had. Whenever you ask generative AI systems questions that are outside your domain of expertise, the answers seem very impressive. But the real way to understand its limitations are by asking questions where you are the expert, and that's when you start to see the cracks appear.
And so, so our listeners and viewers know, what are some basic ways all of us, even if we're sort of scared of technology or overwhelmed by all of this, can just start to play with generative AI to sort of see in relation to our own lives, ourselves, what it is and isn't doing, especially in the limited areas we might consider ourselves experts or semi-experts in?
So I have for a long time been recommending everyone who's asked me questions about generative AI to just say, I think you're the best person to answer how well generative AI works for the tasks you do. It is as simple as going to one of these language model providers' websites, like Claude or ChatGPT. And basically, every time you're sort of trying to accomplish something, whether it is, I don't know, writing an email or writing a letter or figuring out something related to a recipe that you're cooking or writing a piece of code. I think in all of these cases, these are all small test cases for how well generative AI works. And I think it is often surprising to play with these tools simply because, as Ethan Mollick at UPenn has described it, the frontier of generative AI is jagged. So in some tasks, generative AI performs much better than you might expect. In others, where you might expect like a 4-year-old to be able to solve something, generative AI unexpectedly fails. And I think the only way to understand this jagged frontier of generative AI is to play with this tool for a number of different applications to get a sense of where its strengths and weaknesses lie. So for example, coding is an area where generative AI systems have improved exceptionally over the last 5 years or so. Most coders who are sort of work in big companies, when asked in surveys these days, the vast majority of them report using generative AI tools for their work. Most of them report being more productive as a result. So for any sort of programming, anyone who programs for a living, I think it has already changed the way they work. In contrast, for other applications, we've seen generative AI systems being pretty useful, but essentially failing to provide the level of reliability that is required. So for example, in many healthcare applications, we've seen the use of generative AI, for example, to save doctors' time by transcribing doctor-patient calls. And that is indeed a place where I expect generative AI to lead to big gains, big returns in time saved, in the amount of labor reduced for clinicians, and so on. But here, this is an example of reliability being an extremely important characteristic. And we've seen that generative AI models of today hallucinate responses. So they fabricate content that actually wasn't there in the original conversation. And so when this happens for patient transcriptions, this is a big red flag for the use of a product. So this is what we must build around. When we are looking at applications where the barrier for entry is high, the barrier for reliability is high, we must build systems that account for these limitations, that check for hallucinations and so on. But when the barrier for entry is low, when there's a human in the loop who's literally looking at every single output, For example, when I'm using generative AI to write code to create a website, it's much easier to verify whether a response is correct simply by looking at the website a model generates. And so their generative AI use can be much easier.
Would you say then the reason we are sort of witnessing this kind of shaking around us of AI really has to do with how much more advanced data processing and storage technologies are, like what sometimes people call Moore's Law, that, now they have these superpower chips like NVIDIA chips that can process and crunch data and can create emergent patterns so quickly. Would you say that perhaps the technical breakthroughs around all of this were a huge part of the story, which is why we're all kind of wondering what this all leads to?
Yes, yes. In a number of ways, I think the two main bottlenecks for the rise of deep learning, actually, and not just generative AI, back in the early 2010s, were the availability of large data sets and the availability of a large amount of computational power. And so one of those, the data set, was actually addressed by a small academic team at Princeton University that labeled this massive data set of images called the ImageNet dataset. And they organized this big competition to be able to see how well leading state-of-the-art AI models perform on ImageNet. And it was in the third year of this contest that Geoffrey Hinton and his team won the contest by a large margin. In a game of inches, they won by a mile. And the reason for this was they were able to use advances in gaming computational units, so GPUs or graphics processing units, that were initially intended for use by gamers, but they were able to use these GPUs to train language models. And because GPUs have an order of magnitude more processing power compared to CPUs, that is the central processing unit that typically forms the core of a computer, they were able to get much better results. And once this was realized, one of the insights in the paper they wrote about this effort was that there weren't really any limits to how much compute you could throw, or at least they weren't able to reach the limit of how much compute you could throw at the problem. If they trained the model for a longer time, they would get better and better results over time. And so I think this fundamental insight led to a lot of investment, both by NVIDIA as well as other processor creators like AMD, into scaling up their chip manufacturing, into making sure that AI can use effectively these graphics processing units at scale. And I think many of the results that we saw from the 2010s were a result of simply scaling up the models that we developed early on. And then the second advantage, or the second sort of breakthrough, I would say, happened in the late 2010s when Google released a paper on what is now known as the transformer model. So this is the advance underlying a lot of the generative AI models of today. And basically, this allowed all of the text generation type methods that we see used in modern language models start off as well. It was initially conceptualized as a way to translate between languages. That was the main use. But very quickly, we realized that we can also use it for open-ended text generation, and the rest is history. So basically, it just involves scaling up the amount of data we use to train these models, scaling up the amount of compute we use to train these models, and we are still seeing returns from it. Actually, just today, OpenAI released their GPT 4.5 model, which they say is basically just a bigger version of their previous models. It used more compute, it was trained on more data. Of course, we've made efficiency improvements along the way, but the key criteria is just using more data and compute, even to this day.
That's quite interesting because, when I wrote my last book, I was interviewing some execs at Google and some other companies, and they were all describing, this is in 2018 when I was doing these interviews, they were all describing without fail their companies as AI companies. And I asked them, what do you mean by that? Because, I know this AI from the couple of decades ago, like, 20 years ago or so when I was a student, and so it was really notable for me that they were saying that. And then they said to me, and this is really telling from what you just said, Sayash, that that Google Translate is a type of AI system. And I was like, oh, interesting. So it's patterns that they're looking at, and they scaled this up. Very interesting. Very interesting. So I want to ask you about, I'm going to kind of combine these, but there are criticisms all over the place. I'm sure you're highly familiar with it. You probably do interviews about some of this like I do sometimes myself. So I'm going to just kind of mention a couple, and then and I want to just get your response to it, how you see things. First, I have artist friends who tell me that AI has no heart. These are like poet and musician and jazz friends of mine, who are like, yeah, AI is amazing at mimicking things. It could be a tool to catalyze and stimulate me with writer's block, but it has no heart. And I just, let's try to like, I'm just curious how you even react to that, right? I know we're all many identities, but also as a computer scientist, how you see that. Um, the second thing I hear a lot is that intelligence is not merely, and I alluded to this earlier, is not merely restricted to human beings. There are many examples of distributed cognition, what people call, orcas, bees, whales. I mean, tons of bird songs, etc. So, like, why are we anthropomorphizing intelligence rather than looking at intelligence on a more planetary level, on a more ecological level? And then the last thing is, I'm kind of throwing them together. We can break them apart. Is, when we talk, often when engineers talk about black boxing, they talk about the system itself, like you were kind of alluding to, the interiority of a system. But if you actually want to black box AI and what it signifies around the world and around the planet, we need to include minerals, laborers, content moderators who do some of the labeling. I'm friends with content moderators and people running data unions in Kenya. I'm bringing them on this podcast too. You probably know about some of these people. So the black boxing seems to be a black boxing that is also needed for public and global benefit. So we look at what are the costs and what are the benefits when we, instead of seeing AI as some sort of like airtight, smooth black box. So curious what you think about these points, sir. These are common things I'm sure you've heard before.
Yeah, I think they're all very interesting questions. Maybe I can take them in reverse order.
Sure,
So I
wherever you
think
want to go.
like the type of like transparency you mentioned about content moderators or people who are labeling the data used to train I think that is precisely the sort of transparency that's needed. And unfortunately, I think the focus on the internals of the model sort of obfuscates the need for this type of transparency. It shouldn't in principle. In principle, it should be possible to sort of think about both. But oftentimes, when companies talk about transparency in AI, they basically refer to this technical notion of transparency rather than transparency about how the models are trained, what the labor conditions are, what sorts of content is being moderated, and so on. And I think that is an unfortunate consequence. And I do think like if we are to focus on improving how AI is built and how it distributes wealth and distributes labor across the world, I think this type of transparency is crucial. We need to know how well workers are paid and ideally be able to improve worker conditions. So I mean, in the training of OpenAI's latest series of models, there were several reports of people in Kenya actually being paid below market fair wages in some cases.
Yeah.
And the work was also quite harrowing, right? Like it was looking at images of self-harm or text about child sexual abuse materials and so on, day in and day out for days on end.
Yeah, and to
And
interject one thing quickly in there, I sometimes show in my classes a 60 minutes. You've probably seen this, that goes to Nairobi where I do field work in other ways. I look at electronic waste there, in my sort of more anthropological field work. But it actually describes and interviews these content moderator workers and the horrible conditions they're going under. And much of this reminds me of discussions we had about social media content moderation before that, like workers in the Philippines and other places. My colleague Sarah Roberts does a lot of great work on this. And also what we used to talk about, and you're a South Asian like myself, I sense, and we used to talk about concerns we had about call center workers in similar ways. So just wanted to just add that point. Thank you. Yeah.
yeah, no, absolutely. I think the very reason we have this infrastructure in place to create these large data labeling pipelines is in some sense because of social media. I think it is very much an extension of like the social media content moderation pipelines where millions of pieces of content daily are sort of referred to like human beings who have to sort of go over and figure out whether something is a post that is promoting self-harm or child sexual abuse materials and so on. And so that is like absolutely crucial. I think we definitely need to push companies on that. And there have been several efforts trying to do that. And I think maybe this is related to the first question, which is about AI and art, where I think, of course, there is the philosophical question of can machines create art? But I think there's also the more practical question of who gets to benefit from the creation of machine art. And I think what we've seen so far is companies have trained these models to create images based on descriptions of text. These models have actually become really very good over time. Like if you, for example, ask it to create, let's say, a stock image for or some any stock photograph, a logo for your startup or what have you, you're likely to get very compelling responses, things that are good enough in most cases to serve your needs. Unfortunately, this is also the type of low art, if you will, that basically was the bread and butter for a lot of artists who otherwise would not be able to support their high art. So in other words, I think what we're seeing with generative AI is it has replaced many of the things that artists depend on, many of the commission work, like projects that artists depend on in order to support themselves as artists. And the kicker is that this was done because generative AI companies have been able to train on all of the data that was already out there, that was released by these artists online, and use it without consent or compensation in order to create this artwork. And I think like there have been several sort of mechanisms proposed to address this. One of these is the opt-in mechanism, where artists need to individually label all of the content they put out and mark it as not for use by generative AI companies. I think this is entirely unlikely to work, simply because both like any individual piece of art contributes very little when it comes to the training of these models. Also because many artists are likely to be unaware. The models that have already been trained on these data sets are already out there. And on the whole, I think there is this huge challenge of coordinating millions of artists to do this on every single piece of content. It creates a lot of labor for a lot of people. On the other hand, there are like structural things that we can do once we recognize that this is a structural problem. For example, the more radical ideas are to tax AI companies and redistribute the profits as funding for the arts. And there are other things that have been proposed in a similar vein as well. And I think this is what is much more likely to actually be effective, as opposed to requiring individual artists to sort of label their content as not for AI training. And then the final question, which is more about text models and intelligence, and how we can think about networked intelligence when we are looking at AI. So I do think the anthropomorphization of language models is quite unproductive. I think it is better if we look at them as black box systems that can automate certain types of tasks, and we have to build scaffolds around it, very similar to previous waves of automation. Of course, they can do a lot many more things. They can write code, they can do other sorts of creative tasks, but it is still like a black box system that you're basically using as a small part of a larger system. And it is our job as engineers to create systems that work well with these black boxes within them. And I think the reason people haven't really compared language models to like bee intelligence or orca intelligence is simply because they've been trained on human corpuses of text. And so how they output content is very similar to how we've seen content being outputted in previous waves of internet content creation, for example. It is not a type of intelligence that we've come up with from first principles, where we sort of try to create this distributed system. There are people who are trying to use LLMs in that way. There are all sorts of like multi-agent projects that try to sort of look at how different language models can basically coordinate. One can solve a particular subproblem, another can solve some other thing. But at the end of the day, I think the tendency to anthropomorphize them as humans is simply because they're trained on human data and they're fine-tuned to behave as if you're talking to a human being.
Because it's not even if we make the human the point of reference, human intelligence is far more than even rationality. I mean, and sometimes humans are not very intelligent, and including myself. So what I mean by that is, there's Nobel Prize winning work on emotional intelligence. There's also Nobel Prize winning work by people like Daniel Kahneman, rest in power to him, on irrationality, and behavioral economists like Dan Ariely, Daniel Kahneman, all these people. I mean, Kahneman is like the icon of that work, in my opinion. And then so maybe what we need to do is, instead of using words like artificial intelligence, or even assuming it's sort of a human thing, we maybe need to come up with a better language to characterize what these are and what these aren't. To me, they're extensions of a certain type of, generally in the human intelligence, which is exquisite pattern recognition, but it's obviously much, much more than that because of the scale, as you mentioned, and the speed of computation, the ability to take certain types of human actions and activities and do them in superhuman type ways. And now I'm not talking about the AI systems as Terminator or whatever, like people like Jeffrey Hinton talk about, or even Harari sometimes, but I'm talking about them more as sort of scaled up versions of certain types of, now I'm going to be nerdy, deterministic human activities, right? Like it's like I feel like there's a lot of work that needs to be done to clarify what these are and what these aren't to audiences, so we don't continue to live in these worlds of spectacle and
Mhm.
full of anxiety, which is kind of what contemporary political life is like now in this country too.
Absolutely. I like to think of them as cognitive task automations. So
Ah, see,
just as
that's really good. That's really good. Yeah, good. Please, please. Yeah.
yeah, so just as we had like tools to automate physical tasks, and the previous industrial revolution was all about building these tools in a better way, and then using electricity and so on. We now have tools to automate certain cognitive tasks, and I think, in some sense, the transformative potential of AI is the ability to automate certain types of cognitive tasks at scale and across the economy. And I really like Jeffrey Ding's book, which is called Technology and the Rise of Great Powers, which sort of looks at AI as a general purpose technology. So it is not a new species, it is not the Terminator, and it is not a stochastic parrot. It is basically like a type of tool that we are using to automate certain types of things. And he says that, look, we've had these transformations in the past. We've had general purpose technologies in the past. He looks at all previous industrial revolutions. And he points out that unlike what many people today seem to be claiming that AI will transform everything in the next 2 years or whatever, that the diffusion of general purpose technologies to the productive sectors of the economy takes a long time. And the diffusion is when the impact of these technologies is realized.
Right.
So it is something that takes like decades to reach healthcare and education and finance and banking. And a simple reason and a simple statistic that you can think of is, back in the early 2010s, cloud computing was all the rage. It turns out that I was looking up the statistics, 10 years later, in 2023, only 10% of companies had adopted cloud computing.
Huh.
Only 10% of them relied on some sort of external server. Most of them were still operating their own PCs. In many cases, I think it was just the same hardware as before. Even if the hardware had been upgraded, they hadn't really sort of shifted to this internet era of working. That
Mhm.
number might be 25%. I'm forgetting right now, but
Sure.
either way,
Sure.
it's a small number in terms of adoption. And
And
if
just oh, go ahead, please. Yeah,
sorry,
sorry.
I'm just saying, like, if the impact of AI is to come from adoption and not just from building better and better models, then it just seems likely that this will be a process that takes decades, because it doesn't just rely on technical improvements. It relies on training the workforce, on improving AI literacy, on making sure that people know how to use these tools, and improving the reliability of these tools as well. And so that process will take on the order of decades and not years, not even months.
It's first of all, I really love the way you recharacterized it as cognitive task automation. I think that's really important. Thank you for saying that, and I hope you just put out more and more work that helps us re-clarify what these are. I also really appreciate and am right there with you about the importance of considering work and people and workers and economies of the present and future, given how incredibly unequal the economy, the global economy is, and the domestic economy directly tied to the election of Donald Trump. And I love and appreciate that point because if you take a long view through to various previous forms of automation, including automated technologies during the Industrial Revolution, automated technologies like forklifts, the effect was felt. It took some time before the effect was felt. However, what was sort of implicit in your point, which I so agree with, but I don't feel is really out there, is a similar energy, not just to sort of say AI is or cognitive task automation is important and here to stay, but also a similar sense of care about laborers or about economic proposals that ensure that we don't all kind of get further and further feudalized, as some colleagues, my previous guest on this podcast, Yanis Varoufakis, points out. He calls it techno feudalism. Um, or even a consideration of the ecological questions around this, or even what you said at the very end, which I love, AI literacy. I don't see much of any of this happening. I see a lot of, again, as I said, kind of anxiety and delirium combined, which are kind of feed off one another, right? It's which is really gets to this question. So where are we on all of those? I'm right there with you in trying to make those things happen. You know, you have an ally in me. Um, and what do we need to do to get to a point, given that it's private companies who don't in their, it's not really in their interest by definition to do much around any of these issues. Like, so where are we at with kind of ensuring we're innovating in multiple directions? And some innovation is about resourcefulness too.
Yeah, I think it is just really unfortunate that the first 2 years after ChatGPT was introduced, policy conversations were pretty heavily focused on the existential risks of AI. So I think there was a big concern that, AI systems like ChatGPT or the ones that come soon after will literally lead to the extinction of all of humanity. AI will sort of take over in some sense. And I think this was fueled by all of the visuals that we've had from science fiction. Actually, President Biden was reportedly spurred to write the executive order on AI back in 2023 after watching the latest Mission Impossible film, where the villain is a rogue AI.
I didn't know that. Okay.
Yeah, and so it was just staggering the extent to which policy conversations had shifted in that direction. Fortunately, I think in the last year or so, we have seen a more balanced conversation happening in AI, especially at the state level, if not at the federal level. We've seen a lot of legislation that is focused on the real harms of AI that is already occurring, one of which is AI-generated non-consensual deepfakes. We've seen over 100 bills passed in various state legislatures,
Wow.
over 700 introduced. And even at the federal level, we have seen bills that are aiming at promoting the beneficial adoption, creating guardrails, and so on. So we've seen the AI Civil Rights Act that tries to get at some of these. We've also seen initiatives for improving AI literacy that have been introduced in the Senate. So I think I'm a bit more optimistic about the next few years compared to my take on the last few, where we are seeing this, like the policy wheels sort of slowly catch up to what the real risks of AI are likely to be. And at the same time, I think we're also seeing a renewed interest in improving our understanding of how well AI really works in a number of cases. In academia, I think a big shift has been sort of focusing on evaluating these models and how well they really work to sort of allay fears of sudden and drastic automation happening in industries. Because I think that is part of the concern that people have. And of course, it has affected a large number of people, for example, artists and translators and transcribers. That said, I think concerns about broad economy-wide AI-related job displacements are probably at this point premature. And I think we need a lot more data, but I think we're doing a lot of it already, and I'm optimistic about that.
Yeah, I would say that the job displacement concerns are less directly tied to AI right now, but more largely tied to what has occurred with big tech and the gigification of the economy. I don't even know if that's a word, gigification, but sort of part-timization of work. This is what, when I was interviewing labor leaders and labor union leaders around the planet, but also here in this country, they kind of were concerned about that. And again, the vehicle of this kind of amplified inequality that we're facing in this country, which is directly tied to this economic populist right wing that's taking over, that has taken over the state, including big tech people, and as part of that, is not caused by tech, but tech, the directions of who is governing and driving tech seems to be a vehicle that is amplifying those concerns. So I want to, ask you about your thought on what I just said there, but also, if you look some decades ago, John Keynes, the very famous economist, said that advancing automated technologies would mean that we should have a 16-hour work week. All right. So this was said decades ago, right, by John Keynes, John Maynard Keynes. Um, Several months before the election of Donald Trump, Senator Bernie Sanders, and this was something we talked about. I worked policy for him 4 years ago. we talked about the a 32-hour work week. Of course, there's a lot of discussion in mainstream circles about things like universal basic income, but there are also more other all sorts of other proposals. I Andrew Yang was on this podcast. We talked a lot about data unions, and Andrew's a very thoughtful guy on these issues. So there's concerns paying people for their data. Jaron Lanier and others have talked about data micropayments, right? Others have talked about equity in these companies through some sort of blockchain token, even if it's minuscule, that as they advance in valuation, we also have some sort of equity. Um, given that economics seem to be driving in political life and in just people's lives, it's sort of like in the hierarchy of needs, it seems very, very important. Um, what do you see as a more positive set of outcomes for AI, which, I think of you as a really leading figure in? Um, what would be the right kinds of economic proposals, and how do we develop the will to enact those things, given some of the issues and the distress many people have about, I mean, this may not be something you want to talk about, but the American government or other governments around the world at this point, who seem to be beholden more to their donors than their citizens?
Yeah, I think that is like a very, very sort of that's the big question, right? And I think if we look back to the past sort of general purpose technology transformations, after the Industrial Revolution, you had essentially a period of decades where labor was at a big disadvantage compared to where they were before, and it was only 6 decades later that we sort of caught up to the living standards and the quality of life, and so that's certainly one issue. I think at the same time, the institutional progress that we've made since then is, in some sense, being tested right now to see if it holds up to the demands of populism. And so, I mean, we're yet to see what comes out of it. But my sense, again, is that, I mean, especially in the US, but all over the world, we'll see, at least to some extent, these institutional mechanisms being tested with AI. And so that includes the ability of federal agencies to work on mitigating centralization of power and increasing competitiveness. That includes things like providing social welfare, at least not, even if not in the US, but in other parts of the world. And I think one of the things that does give me some hope in these times is also the fact that we are continuing to experiment a lot with the social policies that we might need as we increasingly try to sort of automate a larger and larger portion of the economy. So one example is all of the experimentation on UBI. I think we've spent, over $100 million collectively in the last couple of years on UBI-based experiments. And they have led to certain like very tangible, actionable insights about how to administer benefits, about what types of benefits are best, whether direct cash is best or like in-kind benefits are best. And I think we'll continue to need to do this at least for the next few years as we figure out what like works best. And I think slowly but steadily, we do need to implement some of these like basic social security benefits as we come up to like the point where this actually starts to become a major deal for a larger portion of the population. I think we're in the early stages already, honestly. A lot of that work has been set back by the recent cuts to USAID, for example, which was running many of these experiments. But at the same time, I think we have like a wealth of knowledge when it comes to what works best and what institutions we need to decide. And we are becoming better, at least at getting that knowledge day by day, even if not at actually implementing these programs.
And all the more reason to experiment and look at different kinds of policies and different types of programs if we can't count on necessarily the federal government to support such. Also, this can be done in state, local ways. I mean, Sam Altman, co-founder of OpenAI, I interviewed him also in 2018, and not for discussions of OpenAI, but for his private funding of universal basic income initiatives, which I'm sure you're familiar with. He was working with the city of Stockton, whose mayor is or was a quite wonderful guy who really cared about these issues. This is great. So there's another kind of angle on this is there's different geopolitical questions around emerging AI as well. So, of course, the DeepSeek revelations made a lot of waves. Now a few weeks ago or a month ago, when at the time of this recording, there was some discussion that DeepSeek was able to develop a quite exquisite chatbot that emulated, if not surpassed, some versions of ChatGPT, OpenAI's flagship product, for pennies on the dollar, though it wasn't quite, this kind of 6 million to 100 billion or whatever people say. It's not quite that. So, the Chinese seem to be blazing forward with different kinds of experiments in AI. DeepSeek did engage with the open source developer community, which I think is a really important story in technology of developers around the world who just want to like help each other. And that's a beautiful part of the story of technology and free software too. And then, of course, there's this the Europeans, who I engage with sometimes, some conferences I speak at, tend to have an inferiority complex around tech and AI. They may not like those words, but they're like, we're behind, we're not innovative, we don't. And so I always tell them, like, innovation is not just sort of spending trillions of dollars with little to no economic benefit for almost anybody but a few companies. That doesn't seem very innovative. Innovation is about all boats are lifted, right? Including those of brilliant engineers and executives and so on. We don't need to be zero sum with this thinking. So this is a setup for a question, which is, how do you see different kinds of approaches toward AI that might be tied to different parts of the planet? Because I, of course, haven't talked. We only alluded briefly to Africa, to South Asia. We haven't even mentioned South America. There's a so where are you seeing kind of different approaches, different strategies toward AI that you can trace to different parts of the world and even geopolitical questions as well?
Yeah, I think one of the sort of things that was somewhat hidden in the conversation around DeepSeek was just the fact that DeepSeek had managed to actually develop a lot of core technical competence and improve how well we can train models in the process of training DeepSeek V3 and the later R1 version that was based on it. So in particular, I think DeepSeek and all Chinese companies are facing the brunt of American export controls that ban the export of the most powerful NVIDIA chips and the most powerful chips, but basically affecting NVIDIA the most to China and a number of other countries. What this means is that Chinese companies are limited to chips that don't have as high of a bandwidth or computational power as some of the other American alternatives. So in particular, the chips that we are using in the US are H100 chips, which were state of the art until a year ago, I would say. But the chips that are exported to China are the H800 chips. And then there were a new series of export controls that even banned those chips. So the latest version is just the H20 chips, which are far slower and have much less memory compared to the H100s. Many of the innovations that the engineers at DeepSeek did were actually meant to get the most juice out of these H800 chips. So they were sort of basically innovations to get to where American companies start off at, in some sense, because they have a lot of increase in, or they need to increase the amount of memory these chips can process simultaneously and improve the way in which these chips can train machine learning models. They can improve the efficiency of those. So in some sense, the technical advances were impressive only because they were able to get much more juice out of systems or chips that were not really the state of the art. But that said, I think by most metrics, DeepSeek R1 as well as V3 were far behind most of the models trained by US companies. And this gap is only likely to get larger as export controls continue to remain in place because the chips in America are improving. NVIDIA launched their latest B100 series of chips, which are nowhere close to being exported to China. And barring like some sort of centralization of compute in China, it seems very unlikely that Chinese AI companies will be able to train state-of-the-art models. At the same time, we are also beginning to see the diminishing returns from using more and more compute for training larger and larger models at this point. We've been doing this for the last half a decade. And at this point, many people are speculating that we are basically near the end of what is called scaling laws for scaling up these models and getting better and better performance. So how much it matters for end applications, for the systems that we build using these applications is still up in the air. It might turn out that even despite using like an order of magnitude less compute compared to their US competitors, we still have models that are basically the same for most tasks. And it's only at the very high-end specialized tasks that these models do better. So that's sort of where I see the technical progress in China. I think there are strong headwinds to how much better they can make their models, especially with the lack of new chips. But at the same time, we are, I think, already at the level where these models are quite capable already of being able to be used for a large number of productive tasks. I think when it comes to Europe, there are a number of companies that are trying to make advances in these foundational models. So for example, Mistral AI is a French company that continues to train some state-of-the-art models, frankly, when it comes to open source AI. And they release many of their models openly, but they keep sort of their business models, they keep the largest models closed source, which they charge companies for, but then release the smaller models as proof of their technical competency. And so I do think there is some competition there. Of course, the immense amounts of capital expenditure required to train these large models means that they can only do so much. I think they're two orders of magnitude smaller than the Googles and the Metas of the world. And so they aren't able to compete at the very high end. But once again, I think the story is similar to DeepSeek, where you might get models that are good enough for a large number of things. They're good enough for transcribing speech. They're good enough for auto-completing the code snippets you have while running the model locally. They might not be the best models in the world, but they can still occupy a niche and fill it very well. And of course, when it comes to American companies, I think we are seeing innovation happen at all levels of the technical stack. So we are seeing small models. For example, Google has started training their Flash 8B model, which basically can run, it's small enough to run on any computer with 8 gigabytes of RAM. All the way up to the largest models like GPT 4.5. I think OpenAI has claimed it's an order of magnitude larger than the previous GPT 4.0 model. And so I think technically, US companies continue to be in the lead. That said, by this other definition of innovation that you talked about, innovation rising, leading to all tides rising or all boats rising, I think there are significant gaps still in ensuring that companies are transparent about the various aspects of their models. And actually, a European company, Hugging Face, is close to the top of this transparency index that Stanford University puts out, and I have the pleasure of contributing to in a small way, because they are extremely open about the models they train and release. They give out information about the data labor practices. They give out information about how the model is used downstream and so on. And so compared to OpenAI, Google, Meta, all of these companies, they are one step ahead in sort of at least the bare minimum of disclosing how their models were trained and how they're being used.
That's wonderful to hear about these different kinds of approaches. Because one of the stories that at least was surfacing about, so just for everybody who's listening, because this might be old news when we put this out, this Chinese startup that, of course, many Chinese startups or Chinese companies in general are very tightly connected to the States. Okay, fair enough. That's a common theme in China. But they were able to, for a fraction of the cost, we don't need to get into the specifics of the numbers to be apples to apples, we're able to refine and train a language model, an AI chatbot in a sense, like a GPT system, for a fractional amount of the cost. So people are saying because they didn't have access to the latest and greatest of these NVIDIA, which were traditionally gaming chips, you mentioned that earlier, they found workarounds. And some of those workarounds was because of consulting with open source developers and using open source data, which is just stuff that's out there that people have either willfully contributed to or freely contributed to in a transparent way. But I also have heard that they were able to build their models exquisitely by stitching together different specialized language models, AI systems. I don't know. This is kind of hearsay because I'm just hearing this from colleagues of mine who connected with some of the DeepSeek researchers. Because what this gets at is, I think, two different philosophical approaches toward AI. One is sort of like, we talked about this earlier, right? Turn everything into data. And that raises questions about what should not be turned into data. Okay, but say we just want to turn everything into data and then just use superpower, chips to try to induce patterns, out of data through mechanisms that we were describing earlier. Another, which kind of is the old school model in some ways, not quite, but a little bit, was specialized models for different domains and then figuring out ways to create, I don't want to be too technical, but interoperability, but or sort of communicability between those. So this is what I've heard, that the latter is a type of design strategy that the Chinese applied in this particular case. I don't know if you have any thoughts on this, but I just wanted
Um,
to put it out there for this conversation. Yeah.
So there are two things that it could be referring to.
Yeah.
At one level, it is true that DeepSeek was training their models to reason. So I think I put reasoning in quotes because, as we discussed earlier, this might not be like true reasoning, but rather was training their model to sort of output um, what look like thoughts, right? So if you interact with DeepSeek R1, it'll say things like, "Oh," and let's say you give it a coding problem to solve. It'll say things like, "Oh, the user has given me a coding problem. Here are the parameters. Let me try this approach. This does not seem right. Let me try another approach," and so on. So basically, sort of teaching the model to output these strings that seem as if the model is performing some reasoning. And the way you teach the model to do this is by training an earlier version of the model and then running it on similar problems. Let's say you collect coding problems. And then you look at the results of those problems and only keep the results that were correctly answered by the model. And then you fine tune the model in this way on the correctly labeled traces of previous models to induce this type of pattern recognition where you would start by saying things like, let me reason about this model, and so on. So that could be one sort of approach that it might be referring to. You have another model that is used to generate outputs, whether it is for reasoning or for mathematics, especially in domains where the right answer is easy to verify automatically. This type of approach has led to big gains. So if you've heard of OpenAI's O1 and O3 models, this is what they're trained to do. They're trained to output reasoning traces first, and once they're done with it, they give out the final output. And this has been shown to improve accuracy, especially on mathematics and coding. Another thing that it could be referring to is the model architecture choice, which is known as a mixture of experts model. So there, we're not really training different small models, but rather this is just a way of training a machine learning model that is much more efficient when it comes to both training and then serving the model at scale. So instead of the entire model being used to output a single token, which would be known as like a dense model, you have these sparse models, which are mixtures of experts. So instead of using the entire model, your request is just being answered by like a small set, let's say a 10th or a 20th of the total number of parameters, which makes serving this model to like a large number of people much more efficient, because you don't have to store all 600 billion like sort of weights of the model. You don't have to compute the values of all 600 billion numbers to output like a single thing at the end. You basically just have to compute a small sort of subsection of those.
That's really, really interesting, right? That there's different approaches that we can take toward designing such systems, and just a reminder of that in these different cases, in these different news cycles that are going to just keep coming. They're going to keep being part of the world. So, I want to ask you, of course, about your and Arvind Narayanan's decision to call this book AI Snake Oil, specifically the use of the term snake oil. And then after that, in the subhead, you say what it can and can't do. So, just to kind of, in a very simple way, what can AI as of today do, and what can it not do, and why snake oil? What does snake oil mean in this case?
Yeah, so I think the term snake oil comes from these late 19th and early 20th century salesmen who would sort of go from town to town selling a miracle cure to any possible disease. So they would claim that their snake oil can cure anything from kidney diseases to liver failure to back problems and whatnot. And in most of the cases, this basically did not do very well for anyone involved. And the Food and Drugs Administration, the FDA in the US, was created in part because of the prevalence of snake oil salesmen in the US. It was created so that customers can have trust in medicines and know how to separate the wheat from the chaff. And I think something similar is happening in AI today. So generative AI, which is the predominant type of AI system that we've been discussing so much over the last hour, and more generally in the media, generative AI has made these genuine technical advances. It can do things that we couldn't do using computers. just a few years ago. And in general, I think these technical advances are genuinely useful. On the other hand is predictive AI, which is AI systems that are used to make predictions about the future and make decisions based on those predictions. So we're seeing the use of automated systems for making hiring decisions. So given a set of job candidates who should be hired, we are seeing the use of predictive AI for finance, for education, for healthcare, in all sorts of things. But despite being called AI, the underlying mechanisms that, or the underlying technologies that power predictive AI are actually very different from the generative AI systems. We haven't seen big progress or massive progress in the technologies used for predicting people's futures. And you would think that this is common sense, right? Like we can't predict the future beyond like a certain small set of domains. We definitely can't predict which of these candidates would be the best at the job. We can't make predictions about individuals. But when it comes to AI, I think we seem to have suspended common sense in a lot of cases. And predictive AI companies exploit the public's confusion about what AI means to basically ride on the wave of technologies that do work well, like generative AI, and all the while basically reselling decades-old linear regression models as if they can predict the future. And so that is the specific type of AI, and in particular applications of that when used for making consequential decisions, such as deciding who gets bail and who gets kept in jail pre-trial. I think that's the sort of thing that we refer to as snake oil in the book. We don't think it works now. In fact, we have an entire chapter dedicated to why we don't think these applications will ever work because of the fundamental limits to predicting the future. And that's why we sort of call the book AI Snake Oil and not AI is snake oil. I think there's like lots of AI that we don't think is snake oil. And we basically just try to delineate AI that works from AI that doesn't.
So, this is an interesting point also because a lot of AI systems and algorithmic systems of all kinds work with data sets from the past, but in a sense so like for example, you alluded to systems that might inform decisions or courtrooms, award-winning work by ProPublica on the Compass system that we'll link to in the description here, that sort of basically made decisions based on unequal pasts and histories to essentially order the present and the future. So in a sense, you're correct that these systems may not really learn much from history, but they might reinforce history's inequalities to kind of, instead of predicting the future, constructing a more negative and more unequal future. Any thoughts on that?
Absolutely.
Yeah.
Yeah, so the ProPublica investigation was indeed groundbreaking. And I think the key headline finding was that the false positive rate, that is the number of times someone is falsely detained or falsely flagged as being at risk of not appearing for the trial, was twice as high for Black defendants compared to white ones. And I think this racial bias is indeed something we should be on the lookout for. And I think we can sort of end up reinforcing the very harmful stereotypes and the very harmful historical patterns. But I think what was more interesting about the study was actually something that appeared in the appendix of the study, which said that the accuracy when making these decisions was actually 65%. So even if the system was not
Oh, that's
biased at
very
all,
low. Very low.
exactly, and it is being used to inform decisions about who gets to be released to their families before trial and who is essentially detained without even having a trial.
Yeah.
And so if you look at this system, I think a far bigger problem is that we are allowing such systems to be deployed despite this low accuracy. I mean, even a random coin toss might lead to no racial bias, but we wouldn't want that to be the determinant of extremely consequential decisions. So I think in the conversation about bias, we seem to have missed the sort of more fundamental question of whether something even works. And if it doesn't work, then we should basically contest it as illegitimate rather than trying to fix the racial bias within the tools.
I love that because it actually is a way in which we can apply science and experimentation and playfulness to actually make smart decisions about the here and now. So this example that Sayash and I are discussing, that we're discussing right now, asked, folks who it was recidivism, like some might know the movie Minority Report from the past, where it sort of makes a decision of the likelihood that someone will commit a future crime, which they call recidivism, future criminality. Of course, they didn't ask people if they were black or white or male or female or what have you, but they asked questions that are correlated with race, like was one of your parents arrested? So Black folk get arrested a lot more than white folk, partly because of the presence of policing in those neighborhoods, and partly because of a range of different environmental and historical conditions that led to, the greater policing and greater problems that those communities face. So instead of so in a sense, these systems are deeply ahistorical in the sense that history is a long and interpretive. It's a contemplative, reflective view. Yet they're actually just using sort of questions and past data that sort of reinforces these patterns. So that's why we can do so much better. We can engineer and design systems in ways that actually represent a more aspirational vision of the future. Because I remember when reading that paper, people said, all right, well, a racist judge or a discriminatory judge is even worse. But I just think that's the wrong comparison. I think the comparison should be what do these systems do or don't do, which 65% incredible rate, and which is so low, versus what we want of any system, right? So I always say, like, let's be aspirational when we design systems rather than sort of just see them as, oh, well, it's better than nothing, or it's better than something that's already bad. Like, to me, that's not very insightful approach toward design. So I just wanted to say that because we're seeing those kinds of systems be embedded in employment systems like what do you call that? Human resources. We're seeing that also, these sort of biases, and Arvind Narayanan had done a lot of work on this before. I've looked at his work on linguistic biases and CV scanning and text mining algorithms that kind of scan CVs to kind of determine if someone fits or not into a certain category for a job. Of course, writ large, sort of biased against women in science and engineering, which we know there's so many amazing women in science and engineering. But that's also, there were less women in the past in science and engineering, partly because women did the most important thing for our species to function, which is actually taking care of children, which all of us were at some points, right? So I just think the problem is we need a deep view of history rather than this kind of social, this kind of very uninformed social engineering. That's just my rant on it.
Yeah, no, and like, since you talked about alternatives, I think what
Yeah.
predictive AI systems are often meant to do is not just to replace the individual judge or the decisions of like one part of a system. They're meant to replace entire bureaucracies. And so the comparison to predictive AI systems is not like an individual human being biased, but rather the entire bureaucratic process that we've developed to counteract the system's deficiencies, to counteract the deficiencies in any individual's decision making. In other words, we no longer live with the rule of man, like the rule of the king or the rule of an individual who can make decisions. We live in the rule of law. And so the adequate comparison to predictive AI is the counterfactual is this institutional bureaucracy that enforces the law.
I think that's very, very telling at a time when many of us are concerned that we are sort of experiencing an authoritarianism in this country, and an unelected billionaire, I mean, who happens to be the richest person on the planet, who was not elected or approved by Congress, running a so-called Department of Government Efficiency. So let's see what happens, Sayash, with all of this. But that's I appreciate, no one likes the term bureaucracy, but actually what we mean are institutions that are supposed to serve the public good and be checks and balances, and actually experts in particular areas, right? Like, as a trained engineer, I had to learn all these other fields, which kind of turned me into whatever I am. So, we have a world with people who have expertise in lots of areas. Let's work together. I mean, that's my big deep hope. So, okay, final question for you, because this is just the first of many conversations. I have really, really enjoyed this, and I've learned a lot from you. And thank you for joining us. So, this podcast is called Utopias, not because utopias necessarily exist. Even the book itself was a satire written in the 1500s by Thomas More, but because instead of just wallowing in cynicism and feeling like everything's a mess everything's a disaster. We try to talk to people who we think are doing really important work on many different realms to kind of open up our possibility as human beings and living beings to make this world even more awesome than it is, because it's already awesome. So I just want to ask you, a little bit about your own history, how you came into this field. Um, share a little bit about your own history, your own background, like where you're from and what got you excited about working in this area, and then your wider hope, both as a scholar, perhaps an activist, a professional. We'll see, I'm curious where you see your career heading, and what's your larger hope and vision for technology and our planet, your utopia
So
view.
I think my response is going to be one of the more boring responses you'll get, but let's see. So I started my career working at a big tech company. I worked for Facebook for a few years. And this was back when Facebook was implementing the European Union's GDPR, the Global Data Protection rules. And I just realized, I saw firsthand what a single piece of legislation can change within a company. I think we were seeing, I don't know, like a substantial number of people within every single team were trying to think about how the GDPR would affect their team's product, what steps they need to take. And then finally, when it was enforced, we also started seeing how much power this single piece of legislation had over guiding the company's actions. We would sort of spend more time thinking about products. We would think about how to comply. And this just sort of spoke to me in some sense, because I understood sort of the big leverage we have, the big leverage policy has when it comes to dictating how the technology that serves billions of people in the world will be developed, and what questions engineers would ask, what decisions are made by the leaders within these companies, and so on. And so after a few years of this, I sort of left to start my PhD at the Center for Information Technology Policy, which is where I am right now. So CITP is, I think, a sort of unique place in the sense that we have lots of technical experts who work to inform policymaking. So a lot of my specific work is about finding problems that are deep technical research questions, but that somewhere down the line could inform important policy debates. One of these things, for instance, is the question of, should we open source powerful AI models? So last year, we worked on this question with a number of collaborators, including at Stanford, and we came up with a principled way to analyze the risks and benefits of openly releasing powerful AI systems. And once we put it out, that was cited in dozens of policy proposals. I like to think it helped guide some of the questions and conversations that policymakers had on the future of this technology, including the National Telecommunications and Information Administration, which was tasked by President Biden to write a report on this. And so this is the sort of like work which might, and the reason I called it boring is because I think this is small incremental work. In the day-to-day, we're informing single policy decisions or informing what questions get asked by policymakers and providing the technical expertise to help answer those questions. But my hope is that, these acts of informing policy that dictate the actions of big tech companies would, with these small instances, lead to larger technical transformations. So they would dictate tech that is built for the benefit of society rather than just for the benefit of the few. And we've seen it somewhat successfully. We failed a few times, but my hope is we'll continue to bend the curve in the direction of broader public good.
Well, I'm just thrilled to continue to follow your amazing career. This was a fantastic conversation. Like I mentioned, I learned so much. Our audience is going to learn a lot, and this is just the first of many conversations I hope we have. Sayash, thank you.
Thank you so much. This was a pleasure.
Hi, everybody. Your support means the world to us. Our podcast is really focused on creativity, on care, on stories of inspiration, and inspiring characters of all kinds. It's such a wonderful, wonderful way to reach community. This is a labor of love. So the real way we can sustain ourselves is through all of your support. Please rate, ideally 5 stars. Please share this with anyone and everyone you know, and feel free to reach out to us also with suggestions on guests. Reach us at podcastutopias@gmail.com. Thank you, everybody, for your support.